Hello, my name is Tony Mancine, and I'm the director of the Automotive Research and Development Center, or the ARDC. The ARDC was established in 1996 as a partnership with the University of Windsor. Since then, we've grown to become a world-class engineering and development center for all Stellantis vehicles in North America. The Battery Technology Center is our next chapter. It represents the North America battery testing facility hub here for all electric vehicles. This state-of-the-art facility strengthens our ability to design, test, validate, and all advanced battery technologies for future electric vehicles. The ARDC has a hand in every single vehicle produced in North America on behalf of Stellantis through various engineering capabilities and expertise.
Our key value of this facility is to validate the battery's performance, durability, and reliability. We actually run a lot of tests here in this facility to make sure we verify this battery in both normal and extreme conditions to deliver customers' expectation in the whole vehicle life cycle. While BTC is located in Windsor, we support our electric vehicle development across North American markets. So this lab is capable of supporting the whole battery development journey from individual cells to modules, ultimately to the complete battery pack system.
In road test simulation, we have 6 of the 9 road test simulators in North America. This allows us to test all the suspensions, bodies of all the vehicles we make in North America. During road test simulation, we shorten our test to 4 weeks, which is equivalent to 10 years of customer usage or 240,000 kilometers. 240,000 kilometers is almost like driving to the moon. In road test simulation, we have a 4-post environmental chamber capable of testing from -40 to +55 degrees Celsius, full humidity control, as well as sun load. This allows us to test in all the conditions that our customers are going to see.
Our lab is a little bit different from all the other labs. We don't test vehicles, we don't test components, but we test virtual computer models. What does that mean? That means we're able to take computer models and drive them. So a driver can get in, they can evaluate the vehicle model to see how it's behaving. So we can drive on different roads, we can take the vehicle on railway tracks, we can drive the vehicle over potholes, we can even take the vehicle and drive it on a track, for example. And the feedback that we get is more about how the vehicle feels on these different road conditions. Our simulator has 9 directions of motion, which actually enhances the experience by the driver. So we're able to capture every motion of the vehicle by having these additional directions. The changes that we want to make in the computer model are very easy. The driver tells us what changes we want to make, and on the fly, we can make these changes. Changes like, for example, we want to look at 10 different tires from 10 different suppliers, and we want to change also the pressure in the tires. So we can do that on the fly. Whereas if you had to do this physically, you would have to have 10 tires. We would have to then change the tires while we were driving. We'd then come back to the pit stop, then make those changes. The problem with that is it's time consuming and it is also costly. So we're trying to avoid that time and cost associated with developing the vehicle. By using our simulator, we can really reduce the time to product development. We can start working with suppliers early on, make those changes, not leaving all these changes to the last minute where it could be costly, it could be time consuming, going back and forth with the suppliers. So if we start early on, as soon as we have a computer model, we can make those changes, work with the suppliers, and get the right components set up.
The Brake Development Lab was established in 2016 and is one of 2 brake development labs within Stellantis, and is the only one in North America. Behind me is our full adjustable chassis dyno, which we use to develop all braking systems from our smallest Fiat 500s to our largest Ram chassis cab pickup trucks. To replicate real-world experience for the customer, the chamber itself is able to go down to negative 20 degrees Celsius and positive 40 degrees with a relative humidity of 0 to 95%. In addition, it's hemianechoic, which means it absorbs sound and doesn't allow it to reverberate around the chamber, which allows us to take acoustic readings throughout the